So my name is Sweers. I'm a mobile engineer at Uber out in San Francisco. If you haven't heard of us, we are a startup focused on moving people and things. If you've ever heard the pitch, like we're the Uber of something, like we're the Uber. Today I'm going to be talking about code generating your way to happiness, or in Russian, and bear with me here, Kod sustayushi put к счастью? Yes. All right. That's a big improvement over my previous Russian, which was like kartoshka, babushka, and spasiba, which for the non-Russian speakers in the audience, that's only useful if I'm walking around my grandparents' house with a potato. So like I was saying earlier, I work on a team called Mobile Platform. At Uber, we have about 300 mobile engineers that we're trying to support with that. So we work on basically like internal frameworks, architectures, et cetera. And because we have 300 engineers, what that means is that we have to build things for scale. Now, I'm not talking about like, this needs to work on X number of devices or it needs to work in X number of countries, but rather from a developer experience standpoint. What we build today needs to work for 300 engineers tomorrow, next week, next month, maybe next year. We're not sure about that part yet. So a lot of my recent projects at Uber in the last year have revolved around code gen. So when we talk about code gen, what do we really mean by this? Oh, wait, I'm one ahead on this. Okay. What do we mean by this? So I'll give you a quick anecdote. So my first programming professor back in university, he was this old guy named Dr. Mitra. And on the first day of class, he gives us this whole sort of spiel about this is what the road ahead looks like, what it's going to what the different fields are in development that you can go into. And one of the things that he says during this first day is, you might one day write code that writes other code. And everyone in the room just kind of like gets wide-eyed and mind blown about it. And that's exactly what code gen is. And what I'd like to do today is try to sort of illustrate its value in regular development and also go through some very practical examples of how it can be done. So without further ado, what does it look like? Well, it looks like this. So this is using a library called Kotlin Poet, which is made by Square. It's a library with a nice fluent API for generating Kotlin code. So what's actually going on here? Well, we've got a, sorry, this is different. So we have a file spec builder here that is creating a presentation file. We're adding a comment here saying code generating your way to happiness. We are adding an annotation for an author with the name that's me and a site target, and then building it all at the end. And what does this look like when it's actually generated? Well, you get a file like this. It's just a presentation.kt. You've got the comment at the top there, and then our author annotation in line. So you might be looking at this and saying, like, why do this? You haven't quite doubled your work, but you have taken what you could have just written yourself and written it in a weird way with some odd layer of indirection. So let's revisit our snippet here and say, what if we start making these values variable? So we take in a presentation name, for instance, or we take in the comment as an argument, or the author. What if we have a lot of presentations? What if we have a lot of conferences? It's easy to see how this can quickly balloon into something that's sort of untenable for just to be handwriting this yourself. And at the end of the day, what this is boilerplate. And boilerplate sucks. We're developers. Let's automate it. So that's the first big benefit that I wanted to touch on here. Is that it's a huge tool in helping you avoid boilerplate, and there is some degree of that in every developer's life. The other big benefit that I want to touch on is correctness. Now, humans are error prone. That's just that's how we are, especially when it comes to really tedious or repetitive tasks. Computers are less so. In fact, computers are really great at doing repetitive, tedious tasks. So how can we actually leverage this here? So say we have a standard person class here. Sorry, I keep looking back because I'm making sure that I'm in sync here with my notes. So say we have this person class here. It's a pretty straightforward instance. You have a first name, a last name. Now, say we want to go through and add JSON serialization to this. So we're going to use a library called Moshi, which just using it for demonstration purposes here because it's pretty readable from the outset. It's also from Square. So we have this person JSON adapter here, extends this base JSON adapter class typed with our person. Seems simple enough, so let's start writing. So we'll start with the from JSON method, which gives you a reader to read information from, and then you want to return a person at the end. So we'll need to collect our fields in here, so we need a first name and last name, and then somewhere at the end of this, we're going to return a new person instance out of it. So we start reading through the information that we have, and we just want to just read through all the JSON that was given to us. We'll read off each individual key as it's coming through, and then check the values of the keys and line those up with fields that we were expecting. So if we have a first name, then we're going to read the next value string as the first name. If we have the last name, we're going to read the next value as the last name. And yeah, I mean, it seems pretty straightforward. Does this work? Only if your JSON contains exactly those keys, which anyone that's ever worked with a backend system knows they love to send you a bunch of other junk that you don't know about. So what this means is that we actually have to catch this sort of else case to say if we don't recognize the key, skip the values so that we don't run into a buffer underflow situation. So we have to, there we go. So we have to toss this in there. Now, at this point, we're well past boilerplate territory. This only has 2 fields, yet there's a ton of places in here where you could just have accidental issues. What if we have a typo? Who here has ever accidentally gotten the casing wrong on data from the server? All right, 3 people. That's less than I expected. Good job. What if we have the wrong argument order down here? These are both strings. The compiler's fine with it. And we haven't even considered nullability. I think I have to point this out. We haven't even considered nullability in here. This is also just one model, and everyone knows you never have just one model. So this very quickly, if you have one issue every 10 models or something, you've already got at least one issue in here. And that's something that CodeGen can actually really come in and help with because it will do all this stuff mechanically for you in a way that you can trust to get right every single time because it doesn't suffer from human error-prone issues. So that's correctness. And these are really the big 2 benefits that I wanted to highlight. There are other benefits that you get out of CodeGen as well, particularly around validation, where on top of guaranteeing correctness in the code that it generates, it can also given the information that you've given to it about your code, tell you if you're off the rails on something. So Dagger is a great example of this, where it will tell you if you have cyclical dependency cycles and things like that. So what signs can we look for to know that CodeGen is actually something that we should maybe be looking for in our work? Well, boilerplate obviously is one example. A lot of ceremony is another one. So like that JSON adapter example where it's like every time I have this class, I've got these fields and I need to go through and walk through each one of these. Anything that is a value type, so if it's just holding information, especially if you have specs, and we'll get to this in a bigger example later. And tests as well can benefit from this, where if you're generating code for use in your production code, you actually know what your production code looks like here, and you can actually start to even CodeGen fixtures for testing with this as well to make your life easier. All of these are really excellent signs that that CodeGen is probably something that you should look for as a solution. And now, and we'll dive into some tools now to help enable that. So tools. So the first one that I want to talk about is it's kind of a 2-part tool. There's Java Poet and Kotlin Poet. They are separate libraries. Java Poet is a library. They're both from Square. Java Poet is sort of the gold standard in CodeGen for Java. It's used widely by tons of different like annotation processors, CodeGen tools, etc. Kotlin Poet is its new sibling library, which it generates Kotlin, as you can probably guess from the name. Templating is another common tool that you see in CodeGen, particularly Apache Velocity is probably, I think, the most notable example in Java for this. For iOS, I don't think there are any that I can think of off the top of my head. Usually what I end up seeing is they'll use some sort of scripting language like out of Node and use a framework like Handlebars to basically, I hear someone in the audience say yes to that. Oh, never mind. Yeah, so if you've ever worked in IntelliJ and you're setting up some sort of template for like copyright headers or file templates or something, that's all done with Apache Velocity. The third one that I want to mention is SPI, or Service Processor Interface. This is actually something that's built into Java, but it's commonly used in annotation processors, et cetera, for creating sort of indirect extension APIs. So basically what this means is that you can create an interface and anyone can implement that interface and declare their implementations into the manifest included in the jar, such that at runtime you can actually go and say, hey, give me everyone that said that they have they've provided implementations of this. And the last tool that I want to mention is compile testing, which that should actually have a hyphen in there. The compile testing is a library from Google that helps facilitate actually testing compilation units. And what that means for CodeGen is that you can actually write in, this is what I expected, this is what I actually got, and it will actually compile it in memory and tell you, did it compile? If it didn't, what were the errors? And if it did compile, do you want to compare it to what you were expecting? And it will actually do that based on the compilation units, so you don't have to worry about like formatting or code style or anything like that. On the build tool side, there's two main mechanisms for doing this. One is annotation processing, which is probably the most common one. This is actually something that hooks directly into the compilation in Java. You can basically just declare annotations, or you can write annotations in your code, and then you can declare in a processor implementation that you're interested in learning more information about those, and then you'll get called into by the compiler before it actually finishes compiling the rest of your source. The other example that I want to mention actually is Gradle, which I don't think actually gets enough credit in this department. So Gradle is a build system that is commonly used on Android that has a ton of hooks into its build lifecycle. So you can hook into like pre-build, pre-compilation. You can also spin off custom tasks. It's super flexible, and the Android Gradle plugin in Android Studio actually uses this for a lot of its CodeGen under the hood. And this becomes extremely useful for cases where you have CodeGen that you need to do that is based on sources that are not just dependent on what is in your existing source. So like annotations, it's what's in it's the hints that you leave in your code that it's reading. But then for something like Gradle, you might have cases where you want to read information from some remote location, or it's a heavyweight thing that you don't want to run every single build. And it's extremely useful. So now I want to look at some examples in action. These are going to be either ones you might have heard of, and also some examples from Uber. And some of them are going to look really simple, and that's kind of the point, because I want to show that this is really, it's just a matter of thinking about how you want to go about this, and try to decompose these into very approachable patterns. So the first example, I'm off by one here. There we go. The first example I want to talk about is Butterknife. Who in here has heard of Butterknife? All right, cool. That's most of the room. So for those who don't know, Butterknife is a library by Jake Warden, who is a pretty well-known name in the community. This is a extremely popular library in Android because it helps avoid a lot of boilerplate that almost every developer ends up running into. So if you're working with views in Android, you end up having to write something like this, where you've got, so you have a title, and then in your onCreate, you have to go and find that view out of your hierarchy and bind it to your field so that you can start using it later. Once is fine, but then when you add another, you then have to go through and add that binding again. There we go. I'll just stand like this the whole time. So Butterknife comes in here and tries to help obviate some of this boilerplate for you. So what this looks like is basically, instead of having to manually bind every time down here, you just annotate these fields with these bind view annotations and the ID that they're being bound to. And it becomes basically just a straight mapping at that point. And what's nice about this is that Butterknife will then go through and generate all that same code for you, and it also scales nicely with new items as well. So if you add a new one in there, you don't have to go down into your onCreate and add another one or do any sort of manual tracking. Also works nicely for deleting. So what does this look like under the hood? Because that find view by ID code is still there, and all this gets done at annotation processing. How does that look? Sorry, I'm out of sync on slides again. So how does it look? So we have this field here, and now what information can we actually read from this? The context is that we are running this in some sort of foo activity. We have this bind view annotation. It has a value in here that we want to use as this is the target key. Note that during processing time, this key actually gets inlined to a constant under the hood. That's fine. That's what Butterknife needs to see anyway. The type is a text view, and the field name itself is just called title. So if we make, say, like a holder out of this data, it would look something kind of like this. There we go. It would look something like this. So we've got this target, which is this foo activity. We have this ID. We have the field name that we're trying to inject into the type of the binding itself, and the target type that we want the field's class to be. So this is all information totally gatherable during processing, and this is also pretty similar to what Butterknife actually does under the hood. There's a little bit more magic to it where it handles things like inheritance and whatnot, but that's out of scope for this talk. And this generates a class like this. So you can see all these sort of bits and pieces coming together here where you have basically the target class underscore view binding, and then under the hood, whenever you instantiate it, it just does all this binding immediately with the information that you generated. And all this is statically generated upfront during annotation processing, so that it's all basically correct in here. So looking back at our pipeline, basically, we have during annotation processing, reads these annotations, generates this view binding class, and then during runtime, this butterknife.bind method will just do a reflective lookup of that same class by basically just taking its name and attaching this underscore view binding to the end of it. View binding itself during processing just writes itself out to a given location with Java Poet, and that's pretty much it. The next example that I want to talk about is Rxbinding. Who in here has heard of Rxbinding? All right, cool. So a bit of background on this. Some of you that know what it is might be wondering why I'm mentioning this here. Rxbinding itself does no code gen. It's not an annotation processor. It's not a Gradle plugin. It's just a regular library that you use that provides static factories for basically reactive semantics around common Android APIs. So what that means is if you have a set on click listener, it'll have a clicks method that returns an observable of events so that you can it acts as a nice bridge. So why am I mentioning this here? Well, in Rxbinding, there is code gen. So specifically inside this build source directory, there's a task in Gradle called Kotlin gen task. And what that means is that all of these are actually generated. Rxbinding, it has the Java implementations, and then it also has Kotlin artifacts that have extension functions for all those target types. And all of that is extremely mechanical. Such to the point where you could actually just generate all of the Kotlin extension functions and not have to maintain those separately. So how does this actually look like? So this is a pretty classic Rxbinding method. We just have returns an observable of object. It's called clicks, and this will just handle click events under the hood. Skipping some fluff here for readability. There's more on the methods. In Kotlin, it looks like this. So you have basically your function. It's an extension function on view called clicks, returns an object, returns an observable of objects. and just under the hood, it just calls through to the regular Java implementation. We do have to change this to unit in Kotlin. I probably should have just left that out of the talk. So side by side, it ends up looking like this. Now, when you're looking at this, there's some very mechanical rules for how we can translate between these two. We've got the method, the target type here, the target type, the return type, which we do an extra mapping under the hood to convert to unit, and the rest we can just infer. We have some basic rules around. This is a public static method. This comes down to just a regular top-level function. We have the target Java class itself, this RxView class that we need to call through to. And that's sort of the gist of how these map to each other. Now, what the Gradle plugin does is it will actually go through and parse the Java source directly using a library, I think it's Java parser, and look for those elements to blueprint these Kotlin bindings. So, once it has that, it will. I think I'm out of. Okay, yeah. So once it has that, it's able to then generate this code or generate this Kotlin code from this information. The plugin was originally written in Groovy, so you had this interesting state where it was written in Groovy, parsing Java, generating Kotlin. That was a fun weekend. And so let's break this down step by step. There we go. So we can use that same holding pattern again for the information in here. So we've got this RxView class where this method is in. We can pull out these relevant bits into the target, the name of the method, the type that we're extending, and the return type that we want to toss in there. Again, observable just becomes unit, and this is all the information that we need to actually start writing out these methods. And then we can just inline them directly into the generated Kotlin code under the hood. And there we have it. It's pretty straightforward, but it saves a ton of work, especially because a lot of this stuff is just, you're trying to match APIs of Android, and there's a lot of them. And so having to maintain, not having to maintain these separately is a huge win for productivity. And you can even start to put this on CI, where you say, run the Kotlin code gen, and if your Git is dirty after that, then you need to update it. The last example, so that's Rxbinding. The last example that I want to talk about is actually something that we do at Uber called service gen. Now, if you take nothing else away from this talk, take this. If you work in a company where you're working with shared specs or shared APIs between backend and client, whether it be Android, iOS, web, etc., there's no reason, I think, for you to handwrite models or even services, for that matter, for those to work together. And I'm going to show you how we do this at Uber. So at Uber, we use AutoValue for our model objects. AutoValue is an annotation processor. It's from Google that generates backing implementations for basically value types. We don't have a actual value type object or value type support in Java. So what this does is it will go through and generate your toString, hash code, equals, etc. implementations for you. It also supports extensions, which we'll get into a bit later here. So we have a pretty generic rider object. We have an ID, we have their first name, their last name, an address associated with them. And then for services, we use Retrofit, which Retrofit and OKCDP are two libraries, also from Square again, that basically they make it really easy to work with networking, and Retrofit in particular lets you basically define your API service as an actual interface that you can work with here. We use JSON on the wire, and then we use RxJava for reactive semantics on top of this. Now, we could handwrite all of these if we wanted to, and for a long time we did, but it's a huge waste of time. It actually comes to very real time and monetary cost due to human error. My favorite go-to example of this was me. Whenever I first joined Uber and I was working on a basically driver onboarding team where we wanted to show, we wanted to have basically a sort of, not a Clippy button, but like, hey, do you want help? And that would, fine, I won't mention Clippy ever again. Okay, yeah. lost my train of thought completely now. Right. So we wanted to basically have this thing, like if they need help or they have questions, they can go to this, basically called out through like Zendesk. And the way that worked is the server would send down some information about the potential candidate, basically what we knew at the time, like their name, maybe their email, and then we would pre-fill that information to the Zendesk chat when we opened it. Now, when I talked about this with the engineer from server, we didn't actually talk about casing format, which I just used camel case because I thought that was normal. But the server guy, at the time we were writing everything in Node.js, and there they like to do snake casing. And this went all the way out to production without any issues until finally we got a screenshot from someone that said, hey, we get a bunch of reports from Zendesk saying that we're introducing them to people named Null. And that's a pretty innocuous thing, but that happens all the time when you're writing these things by hand. So what do we do now? So last summer, we embarked on a pretty interesting challenge where we decided to rewrite the Writer app from scratch. It was really exciting. We basically, it's a total greenfield project, and we got to make a lot of decisions up front about what we thought were important and what we valued in an engineering culture. And one of those things was that we said we're not going to handwrite anything that goes on network anymore. And so the way that we do that is we use Thrift. Now, for those of you that have never seen Thrift before, it's both a sort of like language and protocol that you can use. It was originally written by Facebook and then open sourced to Apache and then forked back by Facebook and now re-open sourced. It's gone through a few variations, but we use it for the specking language here. We're still JSON on the wire, so it's not like full-blown Thrift, but from a specking standpoint, it's actually extremely useful because it supports models, enums, services. Basically, if it's in C++, it kind of supports it here, which can not always be a great thing. So we use this, and we basically just define all of these API contracts between backend and client in Thrift specs, and then we'll just generate code that matches that. So, and what's great about that is that you can actually generate these intermediate formats, and then you can actually start doing a lot more with it in the middle. So, this has no notion of JSON, but we can actually push in our own logic after we've parsed this to add JSON support for this. So we use a library called Thrifty to parse. Thrifty is made by Microsoft or their SF office, and then we use Java Poet for the code gen, and then we just generate the auto value implementations based on those specs. So we can actually go further with this. So like I mentioned, we do everything in JSON. And AutoValue has an extensions API. So there's an extension called AutoValue Mashi that you can basically mark in your AutoValue classes with a static JSON adapter method. And that's sort of a signal to AutoValue Mashi that, hey, like, I want you to generate a JSON adapter implementation for me. And it will read all this information and generate that implementation for you for free. We do this for all of our models now. For services, Thrift actually helps us here too. So this is how you would define a service in Thrift. It's pretty, it looks very readable. We can actually take this and map it to retrofit services. So it's not totally enough just by this alone. We do have to sprinkle in some extra metadata here to tell it like what endpoint we actually want to hit. But it's not too much, and the backend engineers will usually include all that information up front. So you can add this metadata in as annotations, and then we just read those annotations during parsing, and then generate these retrofit services from this. And now we're in business. But that's just one endpoint, one model. And as we saw earlier, no one ever has just one model. So we've got a bunch of models, all generating for our apps and services. And by a bunch, I really mean a bunch. We've got, I think, 5 or 6 apps at this point. We have a bunch of services. Some of them are internal only. Some of them are for debugging, et cetera. And all of this goes through the same pipeline now. Wiring up this manually would be crazy. So if you've ever worked with a JSON serialization library, you know that whenever you create an adapter, you then have to register it with your Mashi, or if you use JSON, you have to register it with JSON. And having to ask everyone to, hey, if you want to deserialize this, you have to go manually wire it up to something somewhere higher up in the DI graph would be crazy. So what do we do here? Well, this is Java. So factory pattern is here to help us. We can generate that too because we know about all these types up front before we've actually compiled. So we have a library for this called Factory, and it generates classes, just adapter factories like this. Now, this is a bit ugly, but that's okay. If generated code was fun, you'd write it yourself. And you can see basically those types that we just saw are all just checked, in here, and it will automatically figure out which adapter to go and invoke for you. But we have another problem here, though, which is that we have 6,000 of these. So even if we split this all up into one factory, you end up in a case where we have eats models going into Rider or driver models going into the Rider app when they don't need to, and that's just added bloat that we don't need there. After a certain point, this doesn't even fit in one DEX file. So we have to split this up somehow. And what we're able to do is actually split this up nicely into basically different services, which works actually, I think, extremely well because none of these end up getting too big. Each of these is maintained by a different team, and we're able to split these up nicely. Now, whenever we're working with this, the way that we want to solve this is each one of these is a self-contained bit of code. It might have dependencies. And what else is self-contained code with dependencies? Gradle projects. So what we actually end up doing with this is we'll read all this information up front and generate actual sub-projects for this. On the iOS side, we also do code gen, and we've looked at generating frameworks, but I think the Swift tooling is not where it needs to be to support that yet. And these dependencies just become Gradle dependencies under the hood. And now we've suddenly we've got distinct slices within our service architecture that someone that is using Rider, they can just depend on Rider. They'll get pricing models with that. They'll get gift card models with that, and it will all be resolved for us and handled by the build system under the hood. But now we have one more problem in here, which is that we have n number of model factories. And this actually becomes a problem again because these are all being compiled in different compilation units. And in annotation processing, you can't strictly, you can't read another external dependencies annotations and do extra code gen on that. So the way that we handle this is we actually have some support in this factory library that helps us, again, with a clever trick from data binding, which is that it will sprinkle in metadata into the jar class path and leave that in the jar that whenever we consume it at some app scope level, we just go to the class path, filter on these files, and then read this JSON out of there to know what dependencies are available to us. It's pretty cool. I know it's a bit hand-wavy, but it's factory, and we'll be open sourcing it pretty soon. And looking at how all this fits together here, so we've got Thrifty goes into Parsit. It goes through a codegen tool that we call Jenga, and that outputs Java files. And all this happens before the pre-build step, or before compilation. And then during compilation, this goes into annotation processing. AutoValue steps in, generates the backing implementations. It also calls out to AutoValue Mashi for the JSON support. And factory happens in here as well. And all that is during compilation. And before any of this, we have this project gen component that generates those Gradle subprojects in the first place. Now, if you're looking through this, you start seeing a lot of the tools that we were talking about earlier. Like you've got Gradle, you've got templating in AutoValue, you have Java Poet for the code gen, you have SPI being used for the extensions API here. And I hope you see that they not only work well on their own, but that they compose really nicely to create this sort of orchestra of different tools working together. This scales incredibly well, and it's been working for us for a year now, and no one has to write any of this stuff on their own anymore. How am I doing on time? All right, I'm gonna speed through this last bit here. I do want to leave on a cautionary note here about pitfalls. So CodeGen comes with a lot of benefits, but it is not free. There's a few pitfalls that you should be aware of, namely bloat, actually. So with CodeGen, it becomes very easy to start generating a ton of stuff and lose track of just how much you're generating. So in the Writer app, whenever you actually start digging through the code that we have in there, we have you start to see specific groups of code in there. So Dagger actually accounts for about 10% of the code in our Writer app, and this is a cost that we accept for its benefits. Models actually account for 25%, a lot more. And this is something that we want to try to improve. Manual code, whenever we were handwriting it, often reflects exactly what you need and not necessarily everything available, which is nice because you have models that very much match what you're using. With CodeGen, we actually give you everything up front, and that can result in a lot of unused properties. So the way that we want to handle this is if we look at our Writer model again, you'll see some of these are required and some of these are optional. If you have an optional property that is unused, you can actually just toss that out. And that's exactly what we're going to try to do. We'll have to use some static analysis to actually go and look at the code to see what is actually used. But once we know what's used, we can sort of just pull the string and see what comes with it. And we can remove unused stuff and potentially everything that they were bringing in with them. The same applies to endpoints. So if you have an endpoint like this getWriter endpoint, which if we for some reason didn't use that, we could get rid of it. And if no one else used the Writer model, we could get rid of it too. And we're still working on it, but we're hoping this could actually bring about 40% down on generated models, which for us actually, because it saves on binary size, saves on install time, that really does actually save us money as well. And that's it. Sorry for speeding through the end there. Thank you.
Thank you, Zach.
Yep.
Вопрос?
Yeah, I think we have 3 minutes for questions.
3 minutes?
Yeah.
Окей. Сейчас у нас есть немного времени.
Now we have a few minutes for questions. Please feel free to ask. Just introduce yourself and ask the question.
So the question, does the techniques that you mentioned, code generation techniques, affect the building time of the project, especially a big project like Uber is?
Yeah, it does a little bit. So the question was, does this affect build times? The answer is yes, but it also depends on where you're doing this. So if you're doing this in like a Gradle step, a lot of times you are doing that either on like a cadence, like we'll generate models once a day, not every single time a developer wants to build a project. For annotation processing, there is some support for incremental processing, but it's still, the Gradle team is working on it. But annotation processing is also not that expensive. There is some cost, but this is going to bite me later, but I'm going to say negligible most of the time. You can make it really slow, but I mean, this is during compilation, so you have a lot of runway with it.
Thank you.
Yeah.
Hi, my name is Denny. Thanks for the speech. I wanted to ask, there's an alternative tool called Protobuf. Why don't you use it? What advantages and disadvantages of this tool?
I wasn't in the room when they decided to use Thrift, so I can't really speak to that. But yeah, protos are another great solution for this, especially from a binary protocol standpoint. You get backward compatibility for free. I'd say go with what works for you. I liked using Thrift because the Thrifty parser that we use, we actually need a lot of flexibility out of it, and it happens that the guy that wrote it works in the building next to me, so we go get coffee periodically.
Hi, thanks for the presentation. My name is Yaroslav. I wanted to ask about when you were talking about generating models using Thrifty.
Yeah.
Yeah. You get this if-else blocks, and how do you like insert your custom logic for parsing specific like data types? Maybe if your Android client is not if your Android client has to introduce some custom parsing logic between, I don't know, generating.
Just making sure I understand the question. You're wondering how do we
Like if you need to insert some custom code in the parsing logic, because all of your code is getting generated.
So the question is, how do you get custom rules in the code gen?
Yeah.
I didn't really talk about this much in there, but the Jenga project that I mentioned actually has a full-blown API for you can do pre-processing on the thrift schemas, you can do post-processing on the types. You actually get a lot of flexibility in there, and you can filter on like specific ones you're looking for. So that's basically kind of, we don't use it that much for that purpose now, but that's the idea behind it. And that makes it really easy to, I can write one for Mashi, I can write one for JSON, and then it becomes one line to enable support for those.
Okay, thanks.
Yeah.